we'll learn list searches. There are many operations that you generally perform on the data, like inserting a data, deleting data, insert operation, delete operation, sorting, and one of the most common and time-consuming operations that you generally perform on the data is searching operation. According to the definition, the process of finding the location of a target element in the list is called as searching. There are three types of search operations generally. The first is the linear search, which is otherwise called as sequential search. The second is called as binary search, and the third is called as Fibonacci search. So today we'll learn about linear search. And before learning about linear search, we'll just try to understand on what data structures generally the list searches are performed. All these algorithms like the linear search, binary search and Fibonacci search, all these are performed on the structures, data structures like arrays and on linked lists. But the algorithm used to search depends to a large extent on the structure of the list. For example, it depends on the accessing of the elements in the structure. Array supports random access as well as linear access. So you can perform all these three kinds of search operations on an array. But linked list supports only sequential access. So you can just perform linear search on the linked list because binary search and Fibonacci search requires a sorted list. So we'll see on what kind of list linear search is generally performed. Linear search is generally performed on the ordered list as well as on unordered list. But preferably we generally perform linear search on an unordered list, in the sense unsorted list. And it is generally used on small lists, say less than 50 elements, and on lists that are not searched often. So we'll see linear search with an example. A is an array. So the indexing of A starts with 0. So herein there are 7 elements in the array, and say that the target element is 22, and you have to find whether 22 is there in the given list or not. So the comparison generally starts from the first element of the list. So it starts comparing with the first element of the list, that is A of 0. So we'll check for the equality. Whenever the equality is found, you say that the element is found. So compare 22 with the first element of the list, which is 38. So no match found. Proceed further to the next element in the list. The next element is 99. 99 didn't have a match with 22. So it's not equal to 22. So proceed with the next element in the list. The next element is 15. So 15 and 22, there is no match. So proceed further with the next element in the array. So the next element in the array is 22. So 22 matched with 22, your target. So you say that you found the element at a given position. So 22 is found at position 3. So this is a successful search wherein you find the element somewhere in the list. We'll see how an unsuccessful search looks like. So herein the target element is 88, and we'll see whether 88 is there in the list or not. So again the strategy or the search concept is that you compare it with the first element of the list. 38 is compared with 88, no match found. Okay, so proceed with the next element, not matched. Go with the next element, not matched. Compare with the next element, not matched. Compare with the next element, 44, no, not matched. Proceed further, 20 and 88, no match. 77 and 88, no match. Now you have reached the end of the list, and there are no further elements in the list, and no match found. So this is an unsuccessful search. So the time complexity of the linear search in the best case, average case, and the worst cases are: in the best case, the time complexity is constant time complexity or order of 1. The best case occurs when the target element element is the first element in the list, and you just make one comparison to find the element. So that is the best case. Average case is where the target element is halfway through in the list, and the worst case occurs in two different scenarios. The first scenario where the element is the last element in the list, and the second scenario where the element that you want to search is not there in the list. So the time complexity is order of n. Thank you. If you like the video, please subscribe.